Hello everyone, my name is Nirma. Today I am going to explain about transformation of random variables. This presentation involves the transformation of random variables by emphasizing both monotonic and non-monotonic transformations, where we will define these terms and explore their properties and provide examples to demonstrate their significance in statistical analysis. Understanding these transformations is very crucial for correctly interpreting data and making informed statistical inferences. And we discuss our topic from introduction to transformations by understanding the importance of transformations. After that, we will discuss about monotonic transformations by exploring their properties and examples. After that, we will discuss non-monotonic transformations by taking characteristics and significance in analysis. And finally, we are going to discuss about the applications in statistics by considering practical implications of variable transformations. Let us start our introduction from definitions of random variables. Random variable. Random variable is nothing but a function that assigns numerical values to outcomes of a random phenomenon, which can be either discrete or continuous one. Transformation. It refers to applying a mathematical operation to a random variable. By generating a new variable whose distribution can be analyzed. And monotonic transformation. A transformation where the function is either entirely non-increasing or non-decreasing, preserving the order of outcomes. Lastly, non-monotonic transformation, which is about the transformation where the function changes it from one form to another form, which goes both up and down, rather than consistently increasing or decreasing. Let us discuss briefly about monotonic transformation. In previous slide, we discussed about the definition of a monotonic transformation. Here we are going to discuss about their properties, application, as well as examples for monotonic transformation. And the property we- for monotonic transformation of random variable, it maintains the relationship between their cumulative distribution functions, which are known as CDFs, allowing straightforward analysis of their distribution. And the application for non-monotonic for monotonic transformation is very common in situations where scaling or shifting data is required, such as converting temperatures from Celsius to Fahrenheit. Let us take an example. If y is equal to x plus b, where a is greater than 0, then the monotonic relationship will be given as if x less than x1 is less than x2, then the output y1 is also less than y2. And for non-monotonic transformation, we have discussed about the definition in the previous slides. Here we are going to discuss about characteristics, implementations, and also by taking an example. And the characteristics of a non-monotonic transformation can change the order of the outcomes. And non-monotonic transformations can be implemented by introducing complexities like multiple outputs for a single input. And the example for non-monotonic transformation is by simple examples such as y is equal to x square, where inputs produce the same output values. Well, like if we give y is equal to x square, we have. If we give x as a minus 1, then we will get the same output but as positive. We will get all the same output values. Where when we give the negative inputs also. Let us understand about probability distribution of transformed variables, which is also known as a CDF. And the CDF for monotonic can be described as the transformed variables can be derived directly from the CDF of the original variable. And the CDF for non-monotonic requires considerations, multiple intervals, and potential overlaps in outputs. And the general approach involves determining support of the transformation using integration or summation. And the examples of applications can be considered in various by taking various situations like in statistical modeling, where in linear regression it is common to use monotonic transformations like logarithms to make model assumptions like linearity. And we can use these transformations for risk assessment, where non-monotonic transformations often appear in finance, where returns might be transferred into their volatility measures, impacting decision-making process. And in a data transformation, example, monotonic transformations can aid in normalizing data, making it suitable for statistical methods that assume normality in the data set. And by let us understand these transformation of random variables by taking practical considerations for data transformation, like choosing the right transformation. The choice between a monotonic and non-monotonic transformation should depend on the specific analysis goal and the characteristics of your data and the impact on inferences, where transformations can significantly impact statistical information inferences. So understanding their nature is vital to avoid incorrect conclusions. And in visualization techniques, we use plots to illustrate the effects of transformations, making it easier to visualize shifts in distributions and ensure that the relationship remains clear. And here we are going to understand transformations of random variables, where both types of transformations provides us tools for data modeling, enhancing interpretability, and enabling the application of various statistical methods. And primarily, we are going to discuss about the importance of transformation. By understanding the transformation of random variables is crucial in statistics. And further, that types of transformations. The monotonic transformations are simpler to handle, while when we compare with the non-monotonic transformations, where the more non-monotonic transformations require careful analysis. And the future directions for transformation of random variables can work on focus on exploring more complex transformations and their implications in high-dimensional data analysis. We can go further briefly into about this topic by taking some references, which will provide us a comprehensive guide to the available resources for understanding random variable transformation across different fields, like by considering books. When we explore literature on statistics and probability theory, particularly sections regarding variable transformation, and by also referring some research papers, by reviewing the recent journal activities, discussing applications of random variable transformations across various fields such as economics, biology, and engineering as well as. We can also use online resources by utilizing online academic platforms and educational websites to find tutorials and deeper insights into random variable transformation techniques. Today in this video, we have successfully gained some knowledge on transformation and random variables, where we get key insights from random variable transformations, and we can also have future scope in future research directions by identifying gaps and areas for future study, and also as well as in automation and efficiency by simplifying data preparation, speed up model building, and enhance overall efficiency. And we also have potential applications by exploring further uses in different disciplines. Thank you.